If you're watching this video, it's probably because you've got some stripped out screws, either in the tiny 2.5 millimeter screws going down through the blue plate into the foam red backup pad, or you've got stripped screws coming up through the blue plate into the pad supports. And I'm going to go over this and show you how to take care of that if you do have stripped screws. Now, one of the main reasons you'll have stripped screws in the tool is this area here, the pocket in that 2.5 millimeter, that hex pocket, oftentimes gets filled with material. What kind of material? It could be paint, it could be dust. It could really be anything, any substrate that's being sanded that gets loaded up into that pocket. And what happens is people don't think about cleaning that out before they take this little 2.5 millimeter L wrench and drop it down in there. And if you do that with this little wrench and you've got buildup in here, you're not going to be seated deeply and squarely down into the pocket. When that happens, you then rotate to the left and you end up not being deeply seated, and you round off and strip the screw. So my recommendation before you get into even attempting to do this is get a dental pick or a tiny, very small bladed screwdriver, scrape it down in there, break all of that debris up, and then if you have an air hose, hit it with an air hose and get that residual mess out of there. So you obviously can see here that there wasn't anything. These are very clean. I just don't have a tool where I can show you that. So these are very clean. Now, when you do go to remove your backup pad, and if you have this wrench and that pocket is totally empty, what you want to do is drop the hex head all the way down into the deepest part. It's not an entirely difficult or almost, it's not impossible to break these free because they're designed to be taken off, but you want to seat that small end of the wrench down in there, all the way down in, and break it free. Once you do that, you can turn it over, drop it down into the head, and then just completely remove the screw. And that's the length of your screw there, not more than 1/4 of an inch or so long. So you remove it, set it aside. Do this in an area with a terry cloth towel, like a towel, or in an area where you can drop your screws down and they won't roll off the table. You go to the back, you do the same thing. Drop it all the way down in there, and then make sure it stays square in the hole, and then break it loose. If you don't, you will strip it. Okay, so then I'm going to turn this around. This one's a little more difficult to get to. That's why I have this like 4-inch long ball head Allen wrench, hex head. So I grab that, I pull that out. Now, let's say that the front right screw is stripped. What I do is I take a number 23 drill bit or a 5/32 drill bit, and I make sure that it's at least 6 inches long. So in this case here, this is stripped out. You'll notice I have a jig here. This jig, what I did is I took a couple of pieces of wood, drilled through it, put some drywall screws down into it, 3 inches wide, so that it would just kind of hold the tool in place. If you don't have the time to make one of these, or if you don't have the materials to make them with, have someone hold the tool so that when you're drilling this out, the tool's stable and it's on a very flat surface. I always put my drill in the drill mode, not in the clutch mode, where if you're in clutch mode, make sure it's up to 22 or 21, you just don't want it. You want it to drill this thing out. So we're going to drop this down here. Now you see why I have a 4-inch length drill bit. It's to keep the chuck head of the drill away from the head of the tool. So I'm just going to sit here and I'm going to begin slowly. You'll see the metal. It's drilling out. So I hold the drill perpendicular. Wear safety glasses. You can see how that's all coming out. You can put your left hand on top of the drill. Just drill down very predictably. You can see all the metal spiral out. You can increase your speed. Take a look at that. So you can see how we're drilling down through the head, and we want to get to the point to where we get to that shoulder and the bolt part of the screw, and this should pop here pretty soon. And you see that it pops, okay? When it pops, oftentimes the beveled part of the head of the screw will stay on the blade. I'm sorry, on the drill bit. It'll stay on there and you just slide it off. But this is what it looks like once you snap it off. Then you'll see that the pad is free from the plate. The only problem here now, this backup pad is beat to death. That's why I used it. But the only problem here is you now have the remaining part of the screw that's down in the female threaded brass insert. So unless you can get this screw out, which there is a way to do that, this backup pad is wasted. Now, if you've never heard of left-handed drill bits, this is a left-handed drill bit. If you were to use this bit, number one, it's too short to get into this area because the chuck will hit the head of the tool. But this comes in very handy on the blue plate on the bottom for these screws here. These screws here on the bottom, they're 2.5 millimeter, but they are twice the length. And you can see that here. They're about twice the length of this. They're almost a 1/2 inch long. These long screws go through the blue plate on the bottom. The short screws always go down through the top into the backup pad. Now, if I were to take this screw here, I've not done this on a backup pad. It's not a screw, it's a drill bit. It's a left-handed drill bit. I'm going to try this. Now, turn your drill in reverse. You're not going to drill to the right. You're going to go in reverse. Let's see what happens with this piece here. you'll see with a left-handed drill bit, I just took what was left over in the corner of this backup pad and I drilled this out. I extracted it, drilling it to the left. Now, just for the heck of it, let's take a new screw and let's see if it'll screw in the pad. Beautiful. If you have a left-handed drill bit, and if you use that after you break it off and you extract what was left in the threading, and if your backup pad doesn't look like this, or like this, or like this, or like this, or like this, if your backup pad doesn't look like any of these, but it looks like this, the edge of the Velcro is attached to the foam, you want to save this pad. If your pad is just hammered and destroyed, like you see here, if your pad looks like this, you can leave that stud, that little stud piece in there, and I would highly suggest you dispose of these immediately. If you're sanding like with a backup pad like this, that's impacting the quality of sand and the finish that you're trying to achieve. I'm not quite sure what was going on with these guys here. Anyway, I just showed you how to get that screw out. Now, these 2.5 millimeter long screws that attach the blue plate to the pad supports, one in the front, one in the rear, and the center spindle bearing are difficult to get out. It's even more critical, not the 4 millimeter. This is a 4 millimeter hex. You drop that in that whole square, you can break that loose easily, and you can pull that 4 millimeter center bolt out of there. Now, if you've got your tiny 2.5 millimeter L wrench that came with the sander, make absolutely certain these pocket holes are totally clean. Go back to that dental pick and an air hose. If they're not, I promise you, you will strip these. Drop the Allen wrench into the hole and make sure it's square in the hole. Lay it on its side, square in the hole, and break it free. Oftentimes, if you're my age and you had a cap gun, you will smell that sulfur smell. You'll smell that if this cracks and snaps loose. I'm trying to see if one of these is tight enough to get that to happen. Okay, that's very difficult to break free. So much so that you might be hesitant or reluctant to even try to undo that. The key here when doing this is if that Allen wrench is not deeply seated into the pocket head of that screw, I promise you, you will strip it. In removing these, if they're stripped, you're going to want to hold this tool. Someone's going to have to hold it for you or with you up in a position to where you can cradle it. My suggestion would be to wrap towels around it. If that's what you have, what we do is we sit it between a vise and we put a terry cloth towel in there. Now I'm going to break this other one loose, deeply seated. Pop that loose. You will never strip a screw if you do this the way I'm sharing with you. Same thing here. Deep into the pocket break it. You're going to feel flex. You will feel flex in the hex head L wrench. You will feel flex. The steel will bend. If you use the little tool that came with your sander, it's not going to flex a lot. It's going to really wear into your hand. You'll feel it. Once the blue plate is removed, you have 2 shims. These shims always go back on the tool. One of the shims is thicker than the other. This one in my left hand is thick. I cannot flex it. This one I can flex. All you need to know is that both of them go back on the spindle nut with this locator post. So you put them on there. When you put the tool back together, you then drop the plate on with that locator pin in either one of these holes. Put your screws in. While this is apart, one of the wear points in the tool where we get tools back for repair regardless of air or electric is the spindle bearings that are press fit on this spindle nut. All of my bearings are Japanese quality, Japanese tolerances, and I'm going to show you the bearings. So these are the bearings that we use. Japanese bearings, some of the best steel in the world. I don't want to get into, people are like, buy it here, buy it there. All I'm saying is for our tools, that's what we've decided that we go with. High quality, high heat, grease that surrounds all the balls between the inner race and the outer race of the bearing. These are press fit onto the spindle nut with a special jig that allows us to press fit these in here. And then that is what you're seeing in your tool right here. Why do bearings fail? Why do we change out the spindle bearings? The tool is a very compact, durable, rugged, lightweight tool. In order for it to be all of those things, ergonomic, where it's not beating up your wrist, your forearm, your elbow, your shoulder. In order to get all of that out of the tool, we cannot have bearings. We cannot have spindle bearings this size here. This is for an entirely different tool. You can see how much smaller the bearings are. We cannot have bearings like this here. These bearings last much, much longer, but we cannot have bearings this size. If we did, the tool would be way bigger. The bigger the bearing, high quality grease. The bigger the bearing, the more grease, the more lubrication over time of running the tool. The smaller bearings, the grease that's in here, as you run the tool, the backup pad gets warm and hot in the middle of the backup pad, and that heat travels up through the backup pad that's mounted to this plate, and it travels through the spindle nut, and it gets the bearings. The high heat, the high heat liquefies the grease. The grease will tend to spread, and you'll notice that over time, with the grease being gone, you now have steel balls running on steel balls, steel against steel at 10,000 or 9,000 RPM. they fail. That's not a sign of weakness in the tool. It's just a fact, and that's what happens with high usage and high heat. I've had tools running in the marketplace for 7 years and the spindle bearings last. I've had tools typically with dust extraction mounted or built onto the tool. The vacuum cleaner is creating a vacuum to suck all of the paint or dust up through the tool. And when it does that, it pulls that microfine dust into the spindle bearings. And that can create contamination. It's just all part of what happens. So anyway, I hope that has helped. Just for reference, the smaller pad screws are SPA, that's Surf Prep, A, and then 0766. Oops, there you go. There they are. The longer screws are SPA 0767, and that's to go through the blue plate back into the tool. So let's do this. I'm going to put these shims back on here just so you can see. It doesn't matter which way you put the plate back on. It doesn't matter if you do the 2.5 millimeter screws or the 4 millimeter screw first. It doesn't matter. But I just want you to see the reassembly steps. And I'm going to speed this up just a little bit by using an electric drill. You want to make sure you don't cross thread the female inserts on those pad supports. So make sure you get that screw aligned, and you're going to be doing this on with a, all right, I'll put this away. We use these electric screwdrivers in our final assembly process here in California, because when you're doing 200 tools a day, doing it this way can get old quickly. Now I want to show you the tension that you want to use. And let's go back to the Allen wrench that came in your kit. Squarely, deep and square into the pocket. We're going to put this on here, and I want you to see my finger indentation. And you see the spring in that. Now I'll use a little more of my fingers. I want some spring in this Allen wrench and tightening it. Make sure that doesn't pop up out of the hole. If you're doing this and it pops up out of the hole, you're going to strip it on the reassembly. Okay, now we're going to go to our middle. And we're going to crank down on that baby a little bit. Boom. You want to feel good back pressure and good tension on the screws when you reassemble them. So we got the blue plate on. That's it. That's done. Now, let me show you here how much tension should be on the screw for mounting the backup pad on. I screwed that in there. Okay. So I'm going to deeply seat this in here. all the way in the bottom of the pocket. Allen wrench is all the way in the bottom of the pocket of the head. And this is, you know, you want some good, that's it, right there. Your backup pad will never fly off. It'll never get loose because it's seated perfectly on the tool. What will happen if you don't screw these in the way that I've shared with you here, and by the way, this is Skylar, what's going on? If you don't, I don't even know if you can see me, but that's okay. If you don't screw that back in correctly, you'll be like me a few years ago, where I'm in a kitchen cabinet manufacturing facility, showcasing and demoing and explaining the value of surf prep. I had a plant manager, a line manager, and 10 or 12 operators. And when I changed out my backup pad to a long J hook for a specific application, hooked it up to the airline, started sanding some parts. After about 30 seconds, all the screws loosened up and the entire pad and everything flew across the shop. So you don't want to do that. It was pretty cool. You know, everybody's standing around watching me do this and they're like, what is going on with your tool? And I explained it to them. So it was actually a really good learning session for them to be able to see, you know, what not to do. Anyway, I hope that this helps you out. And you know that we're always available. Call us anytime. Chat Madison. You can call me 951-852-1553. We're here to support you.